Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Imran Birosidi. My metric number is AE190011. And now I will present the simulation of activity 1, experiment 4, experiment 5. Now the activity consists of a voltage supply with 250 voltage, and then the frequency is 50 Hz. Then they consist of voltmeter with resistor, inductor and capacitor. We use the voltmeter to get the voltage for each resistor, inductor and capacitor. Next, we run the simulation when the voltage supply is 10. Wait until the number of the voltmeter and the others number is constant first, and then now we got the I here. This is I, and this is the ammeter, the value of I, and this is the value of power. This is the value of power factor we use for calculate the reactive power. For how we calculate is by power factor equal to, by the formula of power factor equal to cos theta. From the cos theta we find the theta, and then we use the formula of reactive power over active power equal to tan theta, and we use the formula to find the reactive power by Q equal to P times 2 tan theta, and then we get the answer of reactive power. You can refer the calculation by the report and the value, this value. Now we also got the voltage for resistor, voltage for inductor and the voltage of capacitor. Next, we go to voltage value of 20 volt. And then we wait for the constant value. Okay, and this is, and now this is the value of voltmeter, which is, we have to use one of the value. This is wattmeter, power factor, and this is I. This is VR, VL, VC. Next, to value supply. Value of the voltage supply is 30 volt, and then we start the simulation. Then we got the value of I here, and then wattmeter, VR, VL and VC. Stop, and next for 40 volt voltage supply, and run the simulation. And we get the I here, and wattmeter here, power and power factor, and here is VR, VL and VC. Next to the last is 100 volt. Now we get the value of I here, and then the wattmeter shows power and power factor, and then VR, VL and VC. Hello, next we go to the next active, which is we change the resistor of R1 from 100 ohms to 50 ohms. Okay, and then we start with 10 volt voltage supply and start the simulation. And now we get the I value, power value, power factor, and VR, VL, and VC. Next to 20 volt. Start the simulation. And we get the value of I here, and voltmeter here, power, power factor, and the value of VR, VL, VC. Then we go to 30 volt. Now we get the value of I here, and then voltmeter, power, power factor, and VR, VL, VC here, and then stop. Then we go to 40 volt. And we got the value of I here, and then this is voltmeter, this power, power factor, and this is value of VR, VL, and VC here. Lastly, the 100 volt for the last fill-in table. And now start the simulation. Now we get the value of I here, and this is the value of voltmeter here, power, and the power factor, and this is VR, and this is the value of VL, this is value of VC. And thanks, that's all.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Aizil Fikri Raslan. Want to proceed for the experiment 5. So as we can see from this lab sheet, the activity number 2 from the experiment 5 is about the steady state behavior of RLC parallel circuit. So basically this is the connection of the component for this activity, and what we want to observe from this activity 2 is we need to measure the total current, the current that flow through the resistance, the current that flow through the inductance, also the current that flow to the capacitor. Also we want to find the power of the circuit and the reactive power of the circuit. So for this experiment, we use multi-sim simulation. So this is the figure that I have connect based on the activity 2. From the activity, we need to change the total of voltage, which is starting is 10, then 20, 30, 40, 50 until the voltage is about at 100 volt. So this is the connection of the resistor, capacitor, and the inductance of parallel circuit. Next, this is multimeter which shows current. Also this show current. This multimeter show current for capacitor, and this show for the current of inductance. This is a wattmeter that we observe the total of power. So next we run the simulation. Okay, and then we double click the multimeter to show the total of current that flow through this circuit. Next, this indicates the power that flow through the circuit, which is 2 watt, and this we have the power factor 0.66420. Then the current that flow through the resistance R1, which is 199.997 milliampere. Then the current that flow through the capacitance, which is 89.112 milliampere, and last but not least the current that flow through the inductance, which is 314.205 milliampere. So as an addition information, don't forget to put the multimeter value to the AC voltage, just like this. AC, AC. Okay, so that's all. If we want to change the value of the voltage, we stop the simulation. We double click the AC current and then just change the value. If you want to find 50 volt, we just put 50 volt in this. Okay, then click run again. Okay, as we can see, this is the result for the AC when the voltage is about at 50 volt. Okay, that's all from me. Thank you.